one more question.
Yeah.
About the schema, right? In Mongoose, I did the schema representation, but I never followed that schema representation. But still, I was able to insert insert into my collection this new document from front end. I never followed the schema representation.
Okay.
Yeah, so it was like I had this one
Through the model?
Through the model, yeah.
Through the model.
Through the model. I have one user
from that schema.
Yes, I have one user table.
Yeah.
Okay, I have one collection in which I insert the user document.
Yeah.
So initially, I only give the username and password and email. So if you follow for the registration, it only requires username, password, and email. So I only insert that 3 fields into the.
Yeah, that's fine.
That's fine.
Yeah, no,
but in my schema, there is first name, last name, everything.
Yeah, I know. So it just ignores fields that are not there. Okay, so if you the model that the data that gets inserted is has to be a subset of that, or you can make them required. You can say that a certain field is required, so it'll ignore any inserts that do not have required fields. So you could add more limitations, more validation. So right now, the only thing that it validates is the field name, the data type. Those are the default validations. But you can add more validation. Reference, you can add required fields that they match a particular regular expression. Yeah, you can do all sorts of things. All right. Let's see. So we're starting week 11, where we're going to do a little more MongoDB. So we're going to do some of the more advanced topics in MongoDB. The new version of Mongoose does support promises. You can even plug in your own version of a promise library, but it does natively support it. Depending on the syntax that you use, you can either use callbacks like we've been doing for last week, or you can use the same syntax of promises that we've been using in the front end and the web services, using the .then and the successful function and whatnot. They also support a syntax which looks somewhat like entity framework in C#, where you can string together where clauses and selectors and sorters and so on and so forth, and makes it easier for those that are coming from a relational database that are familiar with these kinds of syntax, structured queries, easier to enter and use Mongoose. Right, so I'd like to cover some of that. Also, I'd like to cover when you're dealing with sub documents, documents within documents within documents. Typically, when we filter, the filter is applied to the top documents. Right? So if I want to search for an ID, typically that ID is matched against a parent document. But if that document contains other documents, then we would like to be able to filter them as well. Right? So for instance, if you have a parent that has several children or an array of children, each one of those children will have its own ID. Right? I like to be able to filter against those as well. Right? Just like I can search from the parent, I like to be able to search under the children as well. So I'd like to cover some of that today. To do that, I started working on another example that I'd like to run by you. I don't remember, did we start looking at this example? So this is an example application that I started working on last week that I'd like to share with you that shows how to create an application, a mean application, but from scratch. Right? So from the last couple of examples that I've shown you are running inside of an already existing application, right? It's also a very academic application in that it asks you to put the client and the server both under the public directory, right? And that's mostly because we like to be able to grade you and like to be able to have all this content freely available so that we can navigate to your public directory and see not only your client side source code, we like to be able to see your server-side source code as well. I like to be able to navigate that publicly. But in real life, in a production environment, the server-side code is not made available. So it is not hosted on the public directory. Instead, it is hosted separately in a place that is not publicly available. So the folder structure is a little bit different. I'd like to run that by you today. We'll see how to get started from scratch. I will, go fast on some of the stuff that we've already seen. Right, so I'm not going to stop when I believe you should already be familiar with some of these concepts. But please, if you want me to stop and review something, please stop me and we'll spend some time. Right. I want to get to the server side portion that is somewhat new. The more the embedded documents, embedded filtering, and embedded schemas and things like that. Right. But let's start from from scratch. Let me close this. All right. So the source code for what we're going to look at today is available on my GitHub, and it's under Web App Maker. Okay. So if you go here, right, you'll find all the source code for what we're going to look at for this week, right? Today and on Friday, we'll spend some time going over this application, right? So please take a look at it, and you'll see that the organization is a little bit different. For instance, one of the things that you'll notice is that the server side implementation has been moved away from the public directory. Okay, everything that is in the public directory is by definition is public, right? It's publicly available, right? All the JavaScript is available, the HTML, the images, CSS, and whatnot. All that is publicly available, and this directory structure is what you might expect, right? But notice that the index page is at the top level of the root of the public directory. That means when you first navigate to the application, the index page is the first thing you see. We're saying no longer do we have /assignment / whatever client and whatnot. Right, it's the first thing that you see. But the server side is instead of being in the public directory, is out here in the app, right? And if you go in there, there'll be the top level app.js, right? That is the entry point of the server side code. Plus you have models and services, which are pretty much what we've been looking at for the last couple of weeks. Again, it is an application, a standalone application, instead of running as a subsection of a larger application. Okay. Let's see. Also, you'll notice that the services that we're going to look at today, the URLs, the RESTful URLs, are legitimate URLs. They're full-blown URLs that are specific to this application. When we looked at the examples in the OMDB application we looked at for the last couple of weeks, those RESTful URLs were inside of the context, right, of a smaller application running in a larger application, right? So those RESTful URLs were somewhat convoluted, right? They prepended some namespaces, right? Understanding that this was not the only application running here, right? This was one of several. Whereas this one is its own application, right? It's not dependent on anybody else, right? It's a standalone application. So I'd like to go over this. So here's the application running on my machine. Also notice that this is not being hosted in OpenShift. It's only running on locally on my machine. If you want to try it out, you can just clone down the project. You can do an npm install, right? And you have to have MongoDB running, right? Those are the only things you need to know. If you want to play around with it locally, clone it, npm install, and start up an instance of MongoDB. Okay, and then you're all set. You can just go to localhost 3000 and it'll start working. Okay. So this is an application. This is an application that allows you to create applications. Right? It's like an online IDE, right? Meant to be worked on, used on a phone, right? So if somebody's standing in line waiting for their coffee, you know, and they might occasionally go into their phone and just play around and develop as a developer, right? They might create widgets for web pages, right? And it follows a very common navigation scheme where you start at the top level of a particular entity and you navigate through the children of these top level entities, following several one-to-many relationships, right? So the UML might look something like this for this application. Where is it? Stop screen sharing. The UML might look something like this. You have developers. You know, me being a developer, might want to create several applications. Right, so one developer can create many applications. Right, and an application might be contain several web pages. Right, and a web page might contain several widgets. Right, and there are different types of widgets. There's a whole bunch of types of widgets. Right, so you might have here a specialization where you might have a widget might be a heading. You might have a label. You might have an input field. You might have a paragraph. You might have a YouTube. You might have a map. You might have a table. You might have several types of widgets. Right? You be able to create these widgets, add them to the page, and perhaps reorder them. Okay, make sense? Right, you can extend this. There might be a developer might be one of several types of users. So here might be an end user, right? And they're all people, something like that. You know, me as a developer, I have full control of the application. I can move things around. I can edit the pages. But then I might send a URL to an end user, right, where they can see the page, but they can't edit the page. Right? They can interact with the page, right? They can use the application, they can run the application, but they can't edit the application. Me as a developer, I have full control over the application. Make sense? Everybody okay? As the user interacts with the application, they might be generating data. Right? They might submit forms. They might create a stream of data. They might create data. A particular user for using a particular application. You know, interacting with the application might be generating data, right? Using maybe interacting with a particular widget, right? Maybe an input field or a text area or drop down that they might be interacting with, right? They might be providing data. So we could capture the data that a particular user, as they were using a particular application and interacting with a particular widget. All right. So let's focus on this part. Let's focus on this part over here. All right. Okay. Let me talk about something else as well. One of the common ways of navigating one-to-many and one-to-many, right, is to be able to choose one and then navigate to all the entities that are associated to that one instance. And once you choose one, again, you can navigate to all the records that are associated to that one. Again, as you choose one, you navigate to all the ones that are associated to that one. This is a very common way of navigating, right, in one-to-many. And what you're doing is basically creating a drill down. Right? You're drilling down into a particular spot in the application, right? And then you can go back. Right? So each one of these entities has several ways of displaying. We need to be able to display a list of these, list of applications, list of pages, list of widgets. We need to be able to display one of them, right? I want to list just one page or one widget or one application, and listing one of them, there should be two versions of the listing, right? It could be one that allows me to create a brand new one, and another one that allows me to edit an existing one, right? Okay, and that's exactly how this was created. Right. So let me demo for you what I have so far, and we'll be adding more as we progress through the remainder of this semester. Okay, so here's the very first page. Here you can list all the developers, and you can choose which developer you want to be. Obviously, a better implementation for this might be a login page, right? You log in, you identify yourself, and then you are as that particular user. I haven't done this. I will add that this weekend. So I'll use being able to log in using Passport.js and logging in using a Google account, right? To demonstrate next week when we talk about Passport.js, how to use that to be able to log in using different types of account and OAuth. Here we have a developer. I can create a brand new developer. Alice. Okay, I can create another one. Okay. Then I can go to their information or to be able to look at that particular user, right? So I can edit that particular user. Right. Notice that this is meant to be used on a phone, right? So it's friendly to small screens. I can either delete or edit that particular person, and I can go back to cancel. I can edit or come back. I can go to Alice and either change, say OK, and it goes back. So it's a very common way of implementing, one-to-many, as you drill into the application, right? And using these very common ways of interacting with collections, right? Being able to list list the children of a particular instance, and also edit and create new ones. When I click on one of them, I then see the applications that are associated with one user. Right, so here's app 1 or app 123. I can create another application, app 234, app 345. Okay. I can go back and edit them. Oh, I forgot to put the OK here. So I can't edit it. Then I can navigate to each one of these, right? I can navigate to 1, 2, 3, and I would have pages. So these would be pages in an application, and presumably these pages might have a particular flow, right? The first page, the second page, the third page. They might have a natural flow, right? So I should be able to change the order of the pages. If I don't like the original order of the pages, I can change it. I can change the flow of the application right here. Okay, so these would be the default order of the page. I can create new pages. Okay, 3, 4, 5. I can go edit that page or delete it. And it's gone. Notice that every time I'm at the edit page, if I do a change, right, it goes back to the previous page. Meaning if you delete it, there's no point in staying there, right? It just navigates to the parent page, right? Or when you're done, you say OK, right? It goes back to the previous page and shows the results. Yes.
How can you persist the changed order in the backend? Is there a way to do that?
Yeah, we'll do that. We'll do that. So in the way we did it in the directive, in the directive, I think we did a swap. Right, we swapped, and that's wrong, right? Basically, what I was doing is I was changing the order of where it started and where it ended, right? It gives this weird implementation. What you really need to do is splice it out and then splice it back in the right place, right? And we'll do that, right? But we'll do it on the server side. Actually, we'll do it on both. We'll do it on both ends, right? Because actually, no, we'll do it just on the server side, and then we'll reread the new order, right, and redisplay the content. Right? Yes, I'll show you that. Once we're in a particular page, but once we select a particular page, we can go see the widgets inside of that page, right? And here's just several of the widgets that are available. We have text. These are headers. These are labels. These are buttons. They don't do anything. They have input fields, and I believe that's all. Those are the only widgets I worked on, right? But you can create tons of other widgets, right? Eventually, what I'll add is the ability of editing each one of these widgets. It'll go into a separate window, right? And that window will allow me to edit that particular widget, right? So if it's heading, it'll allow me to select the size of the heading and the text, right? If it's an input field, it'll allow me to select to change the text and the default data, the default value, default text, maybe the placeholder, things like that. Okay. Also, this being a page. Presumably it's a page that the user will see in their phone, right? I should be able to modify the order, so I can change the order of the widget, and notice it's very subtle, but notice that as I hover, it highlights the particular widget that I would be modifying, so that if I click on it, it shows exactly what it is that I'm changing. Make sense? All right. All right. So let's take a look at the implementation. All right. So let's look at the commits. There's 153 commits up to this point. So a lot of this you've seen. So I'm going to gloss over some of this, right? But again, if you need me to stop and want to go over something, please let me know, right? And we can slow down. So let me go back to the beginning of the commits. Some of these commits are larger than we've been using in the previous set of slides. Since again, you should be able to understand more context with less context, right? So let me just go back to the beginning. Okay, my very first commit. My very first commit is just an ignore file, right? Making sure that I'm ignoring the .idea, right, and the node modules, right? Because I don't want to publish that and share that with other developers. They don't care about that. That's very local configuration. This is the simplest Node.js server, right? Just 3 lines of code that one thing that I should have added here is that you have to do an npm install express -- save. Not to forget to do that. Here, this is the initialization of the package JSON, right? To initialize the package JSON, you can do an npm init. Npm init. Right? Npm init will read the directory name that it's under, and it will take that as the default name for the application. Right, so package JSON is a descriptor of your application, right? So that if you want to share with others, but this captures all the meta information about this project, who the author is, how can it be contacted, a short description of the project, okay, the dependencies, right? Other modules, Node.js modules that this depend on, and this is what allows you to just do an npm install, and it downloads and install all the dependencies. Up to this point, the only dependency is Express.js. That's the only dependency. We added the Mongoose library, right? We did an npm install mongoose -- save, and then we started looking at how to implement the schema. So here, first, I wanted to be able to capture the information about the developer. So here's their username, password, email, first name, last name, and notice that I'm selecting as a collection developer. Again, notice that this is the only application. I'm not competing with other applications. I have the database to myself, right? So I'm not sharing this data with anybody. So I can choose a collection as I see fit. So I'm choosing the developer collection to capture developer information. The model it's implemented in app models developer model. Right? Notice that this is at the top level of the directory, at the root of my project, right? In a dedicated app directory, right? In there, I'm going to put my models, my services, my app.js. Notice that in the models directory, earlier in the other example, we only had just a couple models. I think we had just user, and what else did we have? Movies, right? Just movies. That's all we had. And I think in your assignment, you just have users, forms, and fields, maybe, right? So when you have so few models, maybe it's okay to just have it under one directory, just models, right? But I'm expecting to have lots and lots of models in this application, right? So instead of just grouping them all in the same directory, I have dedicated folders for each one. So I'll have a dedicated developer folder. In there, I will have the schema for the developer. I'll have the models for the developer, and maybe some JSON mock data for that developer for testing, right? So I'll have a dedicated directory for each one, right? Again, this allows me to grow if I have many models. To create the model, I just load the schema from the local schema, and I create a model from it. Again, this is the Mongoose model. Yes, this is the Mongoose model that will allow me to have low-level communication with the database, right? Whereas this model, the developer model, that server.js, will provide a high-level API to the rest of the application. Yes, and sometimes this type of module is for access object, right? That encapsulates all the communication with the database. We're using a high-level API. All right, so connecting to the Mongo database. All right, this is very simple. We load the Mongoose library, and we have the database all to ourselves. So I'm going to connect to localhost web app maker. Right, so this is connecting only to the local database. Right, it's not connecting to the remote database. It's only meant to be run locally, but I don't remember if I make it OpenShift friendly. I don't remember. We did create the connection. Right? Connecting to the local database. We're going to pass it around to other modules. In this case, our app.js. Right? Notice under app, there is an app.js. This is the server-side entry point to our application, right? As opposed to the app.js on the public directory, right? That's the entry point for the Angular JS application, right? So there's two app.jses. Careful, right? One running on the server, right? One running on the browser, right? And they talk to one another using web services, right? The app.js on the server uses web services to receive HTTP connections, whereas the app.js on the browser uses client services to send HTTP requests, right? So this is the server side. We're going to pass around this connection so that the connection we can connect to that database. So here's the app.js right now is just ready to receive the connection. From within the server side app.js, we're going to load the developer model. Right, and we're going to pass around the instance of the database, although we might not need it. Yeah, we might not need it. We do need the schema. We load the schema from the model, right? We did this earlier, right? we're just receiving now the connection, the database connection. We start creating the API for the model, such as being able to create a brand new developer, right? So when people register, or as an admin, I can just create new developers. This is a high-level API. We implement it, right? To implement it, here we have the instance for developer, and we save that save or create dot create. Did I misspell that? Okay, I think that it has the same syntax of dot save, and you pass it an instance of the developer, the same thing as dot create. And here, notice that we're using the callback syntax, right? If you pass to a model, you pass it a callback, right? It will call that callback, right? If instead you don't pass that callback, right, and you do a return, right? That save or that create or that find or whatever, all those return promises. This is starting version 4 of Mongoose and higher, right? They started supporting promises, right? Using very much the same syntax as we've seen earlier. For now, we'll use the same syntax of the callback that we've been using for the last couple of weeks. I had a syntax error. Oh yeah, it's module in the schema. Yeah, fix a syntax error. Developer web service. So here's a web service. This is a web service that's going to receive the incoming posts from the client. The client, when you create a brand new developer, it will post to /API/developer. Notice the URL, right? This URL is only for this application. It doesn't depend on any other application. It's not embedded in a larger application. So this RESTful API doesn't need to add any namespaces. The only thing to remember is to use /API or some naming space that you add here, only to distinguish it right against from everything else that is static content, such as JavaScript and HTML and CSS. Everything that we want to any RESTful API that is expected to return dynamic content, dynamic data. Right, we're gonna refer to it with a /API in front of it, right? And this obviously doesn't map to any physical directory called API, right? It refers to a virtual location, right? That doesn't physically exist, but has instead refers to some database access, right? That we're going to implement. Okay. All right, so newer.
So can it be like named everything other than the API?
Yeah, you can use anything as long as everybody agrees on it on the team, right? Many people like to use /REST. Others like to use /JSON, right? So as long as the team agrees on what to use as a prefix, then everything's fine. Okay. But one of the more common ones is to use /API. It's very, very common. /REST is also very, very common, right? It's not enforced, right? It's not. It's only nomenclature, right? And it's a naming convention. So okay, so now that we have the model, we can create the service. We're going to load the service from that we just created. Right, and on the service, excuse me, on the service, we're going to extract the developer from the body, right? Somebody's going to post it to us, and we're just going to pass it to the model to create it. We add support for body parsers so that we'll know how to extract the JSON representation of the developer. We also add Multer, right? And in the server.js, we load the two new libraries, body parser and Multer, right? And not only do they have to be loaded, they have to be configured. Okay, so don't forget to configure them. I see a lot of students that are posting on Katsa that you know, why? I mean, I can't. The body of the element I'm posting comes back as null. Why is it null? I installed body parser, and what I see a lot of them are forgetting to not only load those libraries, but also they need to configure it, right, and set and turn on the JSON parsing aspects of the body parser. Yes.
What are we doing in the second line? Whatever that.
Multer? Which one?
No, in the app.use body parser dot.
URL encoded.
Line number 10.
Oh, okay. So yeah. So the data that is being passed to us is being URL encoded, right? So for instance, there's a lot of characters that need to be escaped, right? And so they're converted so that they can be represented in ASCII, right? And then they can be reparsed back into when it gets to the server, right? You know, they can be encoded in many different ways, right? Form encoding is another way of encoding it. There's several ways of encoding the same data, right? So this is saying that any extraneous characters are encoded using their UTF-8 encoding, so that on the other end they can be recreated to their original representation. Oops, sorry. Also, we are turning on the public directory, right? So we can start putting static content in there. Okay, and we're passing the app. We're passing the app to the server-side implementation, so that can be used by the service to create the express posts and gets. I installed local Angular and routing libraries, right, and created my index page, right. I created. Okay, these are the files. They're large files, so I'm not gonna scroll through them. I also added jQuery and Bootstrap. Okay. And I created my Angular application. Oh, here it is, Web App Maker, and made a dependence to ng-route, and declared my very first web page, right, which is basically the entry point to this page is the list of all the developers. Okay, so when you first come in, you are rerouted to the developer. If you don't say where do you want to go, if you go basically just to index page, you will be rerouted to the list of developers. I declared the Web App Maker Angular application, loaded my local app.js and config.js, and hosted my ng-view, where the content is going to be injected. Here's the beginnings of my developer list, which is just a heading for now. Then in the controller for the list, I'm going to declare a dedicated controller inside of a file called developer controller, developer.controller.js. And here it is. This is the beginning, a boilerplate implementation of a controller, right? It just declares it as developer list and just initializes it, right? It's not doing anything much. I added the glyphicons, but because the glyphicons weren't working for some reason, and I added it's because these were missing, right? The vector graphics for all the icons were missing, so I added those to my to the fonts directory. So the new developer page. So this page will be used for creating new developers, right? So in the developer list, there's a plus sign. If you click on it, you navigate to a new developer. So because I want to add a brand new developer, and so if I click on that hyperlink, I navigate to developer new.view. Notice the naming convention, right? Notice that all my HTML, all my templates for the developer are under the developer directory, but in there I have three versions or three templates dedicated to each entity. There'll be one for listing all of them, the one or within the context, right? One for creating brand new ones, and one for editing existing ones, right? The creating new ones and editing existing ones, they're basically the same, right? But they don't have to be the same, right? one of them could be more involved than the other. Perhaps the creation might only ask for the name, right? Whereas the editing might give you many more things that you could do when you edit it. Right? Once you've created, you could do a whole bunch of other things. Right now, they're very similar to one another. The only difference between the two is that the editing view allows you to also delete it. Right? Not only edit it and change it, but also delete it. All right. So here's notice the naming convention. So there's the one for listing is developer-list. For creating, developer-new. For editing, developer-edit. Right? And again, following these naming conventions, even if it's not this one in particular, right? Following these naming conventions just makes it easier for all the developers, right, to understand, right, very quickly where are they in the application, or what to look for. If I am looking at the application and you wonder, who's doing this? Where's the code that implements this? Right? You follow file structures, directory structures, and naming conventions. You make it so much easier for the community at large, right, to understand the organization of the application, and you stick to it. Even if it's a bad organization, if you stick to it, right, it's much easier to everybody, paint in their head, how the organization, how the application is organized, and improves the performance of the team in general. Okay, so here's the in the list view of the developer, I'm adding a link that allows me to navigate to the new developer page. There it is. It's a hyperlink. Notice that it goes to developer/new. Okay, and the plus sign here. So that will navigate to the this developer new view. Right. So in the developer new view, I've added input fields for the developer, right? Such as model.developer username, email, first name, last name, right? At the top, I added two hyperlinks. One for actually saving. It says yes, I'm done. I'm done editing. I'm done creating, right? Meaning save this in the database, right? Whereas the other one is a cancel. It says I don't want to create new ones, and it just navigates back to where it came from. So the first one, there's the chevron left that allows me to navigate back, right? It's this one here, right? Right, when you do a plus, you have this chevron that allows you to go back and cancel. And this one is the OK that I'm going to use to notify the controller that I want to save this to the database, right? Which is this this chevron here, this OK here. Okay, the new developer controller. So here I also follow a convention. I'm going to put all the controllers. I'm going to put all the controllers for developers all in one single file. Okay, as opposed to, right, another way to organize this is to have a dedicated JavaScript for the controller for each individual template. Right? See that? Instead over here, because a lot of these controllers are almost one-liners, right, or maybe 5 lines, but they all do the same thing. Right? They're very, very similar to one another. Right? I'm going to take 3 controllers and put it in a single JavaScript file, as opposed to having 3 separate JavaScript files. You see that? Because they are very, very similar to one another. Right? And again, this is going to be something I'm going to stick to for each one of the entities. Each entity has 3 templates, 3 controllers in one JavaScript. Right? Same thing for developers, same thing for the application, same thing for the page, same thing for the widget. Right? So we're going to follow this pattern. Again, once you follow a pattern, stick to that pattern, and so everybody, makes it easier for everybody to understand the structure. So yeah, so before we only had one controller in here. We had the developer list controller, but in here we're going to have new developer controller as well. I just added it there. We had the developer list, which wasn't doing much at first. This one is doing a little bit more. The new developer is going to declare an event handler that if I click on the OK sign, it'll call the create developer, and it's going to be handled by this event handler. It's not doing much right now. It's just echoing to the console. It's going to navigate. It's going to use a I declare the controller in the template, right? But then I declare a service, a client service, who's going to take my brand new developer, right, and is going to send it over to the server, right? Remember the way this is organized, right? The template talks to the controller talks to the service. That's on the client side, right? And then the web service on the client talks to this web service on the server side, receiving the HTTP communication. The HTTP, the web service on the server talks to the model, and the model talks to the Mongoose model. Mongoose model talks to the database, right? And then returns callbacks or promises, right? Goes back to the model, goes back to the web service comes back to the service on the client comes back to the controller goes back to the template. Yes? Multi-tier. You know, each tier has their own very well-defined task at hand. Yes?
When you start to like make this, which one to go, where to start?
I like to start at the front end. Okay, I like to start creating the templates, the template generating an event handler for the controller using the web service. That progression, and at each step, you know, each incremental step, I always put a console, right, just to echo the data that I expect that to be there, right? Or I can step through it, either console or stepping through it on the browser or stepping through it on the server, making sure that the data is getting there. I make baby steps, right? So template talks to the controller. I see that the controller is receiving the event handler. The event handler uses the web service, and the web service, I see that it said. Well, notice what I'm not doing. Notice that what I'm not doing in the controller. In the controller, yeah. So here I'm checking to see, is the controller event handler receiving the event, right? And make sure that works, right, before going on, right? And then when I create the web service, I move the handling, the create developer, I move it into the web service, right? And I make it available to the controller, right, through an API. And I hook them up in the controller. The controller used to just have console, right? Now they're hooked, right? The controller is now using the web service, delegating the work to the web service, right? But notice what I'm not doing here. Remember that this is going to return a promise, right? And that promise is going to have a then, it's going to have a function, it's going to have that. I'm not going to do that just yet. Okay, I'm not going to do that just yet, right? Instead, I just want to focus on those baby steps and make sure that the connection, I can establish the connection, receive the connection at the other end, right? And then it'll come back with a promise, right? It'll come back with an HTTP request response, right? And then come back to the controller, and then I'll put in the promises and whatnot. Yes, right? I only want to add incremental code, right? That I can test, I can verify that this is working. I don't want to add here code that I can't test yet. Right? I can't test a promise yet because I don't have a promise yet, right? I can't test that. I can talk to the next tier, right? And verify these incremental baby steps. That makes sense? I think starting from the front end is a better solution. A lot of server-side developers prefer to start at the back end, right? This goes into another debate on whether you code top down or bottom up, right? If you start at the front end, you tend to code bottom up, right? You only code what you need, right? So it says, okay, so I need to create a developer. So here's the functions that I need. Here are the web services that I need, right? So it drives the entire application development. If you start from the back end and without considering what the front end might be, right? You might start writing code very generically. You know, it's generic. It can be used by anybody. It's not specific to what the client might need. I might over design the back end, you know, putting code that I'm not going to need anyway, because there are no use cases that need that, right? So when you develop from the back end, you tend to code from bottom up, right? So you try to things to be generic that have a broad appeal, right, to any user, right? Whereas coding from the front end, you start things being very vertical, right? That I'm only considering these use cases, right? I'm not going to consider a whole bunch of other things that could go wrong, or right? So I like to obviously the effort has to be on both ends, right? The back end is working towards the front end. The front end is working towards the back end. At some point we meet, right? And we agree on what is that on what the two teams might need. Okay. All right. So yeah. So notice that I am starting from the front end, right? So I'm at the web service. Okay. So on the database side. On the database side, the service, where's the service? Notice that the client, instead of just echoing the developer, is going to send the developer object to the server, right? And hopefully there will be a web service listening for this incoming post. Where is it? Here's the service, right? That had an incoming post, right? It was listening for the incoming post, right? And it calls the create developer and delegates to the developer model create developer and passes the object. Notice that this too should handle a promise, right? But I'm not going to do it yet, right? Because the model hasn't even received it yet, right? Hasn't even stored it in the database yet, right? And I don't want to write code that, again, I can't test just yet, right? But yes, I'm gonna have to come back to this and add the then and the success and the errors and on the response and all that, right? The model receives it. There it is. Create the model receives the developer. Oh yeah, so yeah, that was wrong. This is not .save. It's .create. Right, it's .create. Yeah. So I fixed that. Notice that it's using the callback. Right, in the callback, we're gonna wrap that in a promise, I believe. The controller. Notice that the service, the web service, hasn't responded yet. It hasn't responded with the response.json, right? Hasn't responded yet, or with an error. So I think it's a little bit too early in the controller to be handling the then, right? Because we don't even have a response, right? I should have done this a little later, right? I got ahead of myself here, saying, oh, okay, so the response is going to come back with the developer. If the developer comes in, I'm going to navigate the developer to the list of developers. I've created a brand new developer. I'm going to navigate to the list of developers to list my brand new developer, right? So I got a little bit ahead of myself here. So let's, yes.
Wouldn't it be developer.data?
Yeah, actually, I didn't even need this, right? Because I'm not even going to stay in this page, right? I'm going to create a brand new, has been added to the database, hopefully, right? And what I should get back is not even an object, right? I should get just a 200 saying it was successful or there was an error, right? Because I'm not even going to stay in this page, right? I'm going to go back to the previous page where I was that lists all the developers. You see that? So this line, I don't even need this line. This should be like a result or an error, right? And this one should be receiving either a 200 saying that it was successful. I added it, and now you are free to go to the previous page. If there was an error, I am going to stay in this page, right? And look at the error and say, oh, what happened? Maybe I missed a required field or something, or the wrong data type or something. I don't know. Right, and then I stay in this page. So yeah, so I think I should refactor this, not to even do this. I don't need the model. I only need the model to grab the developer and send it. Right, I don't care what comes back. I add the promises on the server. So the server on the model. Right, first it was just creating and not doing anything, right? But now it needs to notify the web service that it was successful or not. The same technique that we've been using for the last couple of weeks. We create a deferred promise. We make the asynchronous call, and then we return immediately with a promise, and then we either reject or resolve in the callback of the asynchronous call, right? In a couple of slides, I'm going to show you how to use the new Promise API that is available now in version 4 of Mongoose. Okay, but Mongoose, for backward compatibility with version 3, still supports callbacks. Okay, so let's look at that. The web service, again, it's also you're going to add the Promise support. If it gets a developer, it sends back again. This should not even send a developer option, right? It should just send a 200 saying yes, okay. It was successfully added, right? There's no need for this chatter because I'm not even gonna display this user in this page, right? I'm gonna navigate to a previous page where I'm gonna ask for the list of developers anyway, right? So yeah, so this I should change to just respond. Oh yeah, I installed the server-side Promise library. Find all. So now that I navigate to the previous page that lists all the developers, right? That list needs to query for the list of developers, right? Which I don't have, right? And notice that the controller hasn't yet been implemented. Not even the service has been implemented, right? So back in the client, back in the controller, this is the controller that we had for the list page, right? For the developer-list page, right? And used to just have declaring the view model. That's all it used to do, right? Very boring. But now we're going to add the feature that when you first come to this page, the developer list page, right? I want to list all the developers, right? So I need to again starting from the top. The developer list is gonna delegate to the local client service. Get me all the developers. Notice I'm not handling then or anything yet. Right? I'm gonna do that later. So this delegates to the service. Here's the developer service, which we only had create developer, right? Which we just finished covering, right? I'm gonna add this find all developers. And which again, I'm just verifying that I've made it to the client. Right now, I'm going to send it to the web service. Right, so here's a client service. Instead of just echoing that I made it to the find all, it's gonna get. It's going to do a get. Notice that I didn't put a return here. See that? I'm not returning yet anything. Right, but I'm gonna have to come back here and put that return, right? To return the promise, right? I'm only verifying that the controller talks to the web service. The controller talks to the developer service. The developer service will talk to the web service, and so on and so forth, right? And I'm checking to see that happy path first. And notice that the URL is nice and clean, /API/developer. No other prefixes because we're not competing with any other web applications, right? This is the entity that we need. On the server side, I am listening for the incoming get, which maps to the find all developers. I try to call these functions the same on the client side and on the server side, right? Again, naming convention, right? Just to get into my head, right, that this client side function maps to this server side function, right? Again, there is no enforcement, Other frameworks do enforce these things, right? That these have to match. Here, there is no enforcement. It's just us being very, very deliberate and careful what we name things. Okay, so hopefully it makes it to the server. Now we're on the server side. Yes.
Can you get back to the server?
Yeah.
What happens if get requests to the same?
Right. Yeah. So if the first one wins, right? Yeah. And so you should not have URL patterns, right? That are not unique, right? And I've seen in Katz there was a question on two URLs that students were trying to distinguish them by query parameters, right? And query parameters are not used by Express to distinguish two URLs, right? So the query certainly you can get at those query parameters from within the function. You can say request.query, right? But the URL, as far as the URL pattern is concerned, right? Anything before the query string is used for distinguishing two URL patterns, right? And so anything after the query string is ignored, right? To do the pattern matching, okay? So for that particular question was that I need to be able to retrieve all users, and then I need to retrieve a specific user that has a username and password, right? So I saw students that they were declaring these two URL patterns, one of them without any query parameters, and the other with query parameters, and Express was always calling the same one. It was not calling the other ones. People were asking, why is it ignoring my other one? It's because the query parameter is not used as a discriminator. Okay, so in that case, you have to implement both functionalities in the same function, right? And then in that function, you needed to see if you had query parameters, you would do one thing. If you didn't have query parameters, you would do another thing, right? And so it's the same. It was implemented in the same event handler, in the HTTP event handler. Okay. All right. Yes.
Change one of the URLs to another word, keyword like for change it to login.
Yes, that's right. So some students did that, right? Instead of find by credentials or anything, they call it login. That's perfectly fine. Yes. Okay. I think that was a better name for it anyway from the beginning, right? Okay. All right. That answer your question?
Yes.
Yes. Okay. All right. So now that the web service has received the request, we go to the model, and in the model, again, I use the same naming convention. Find all developers, as in the same name on the client service, same name on the web service, and same name on the model, right? So that I know that these all three match with one another. And right now it's just echoing that it has made it to the model, and we tie together the web service, right, with the model. Notice that the model, this one we'll need to come back to this, right, because this one's going to receive a promise, right? We're going to have to come back and refactor this to receive the then, using the then to handle that promise. So in the database, right, in the model, right, instead of just echoing that we have arrived, we're going to use just plain find to retrieve all the developers, right? And here's a callback. In the callback, we receive the developers, and in the next slide, we're just going to return the promise from the model, right? And have, now that we're returning this from the model, that I can go back to the service and start. I added the then, right, because in preparations for this promise that the model is returning to me, right? Again, baby steps. In the model, we're going to resolve it, right? We're going to check to see if there are no errors. We're going to resolve the promise, right? That means that on the client, on the web service, here's the then that handles that part, right? The resolve. When we resolve, the clause is called, right? If instead there is an error, right? If error is not null, right? We're going to on the model, we're going to reject the promise, and the web service needs to receive, right? It's going to handle the error for that rejection, right? And sends a 400 status 400 and the error. In the event that it is successful, we do send a list of developers, right? That is coming from in the promise, and we send it back to the client. So on the client side, let's see. On the client side, now that we are sending back a response from the web service, we can return that response to the client, to the controller, right, through a promise. Now the controller can define the then that is coming back from that from that promise object and handle either the list of developers if it was successful or an error if it was not. Yes.
Wonderful. We used to parse the data function response and dump data to get the data. Now we just
In the controller.
yeah,
On the client side, we do, not on the server side. On the server side, we don't wrap. It does not wrap it inside of a response object. Yeah, the controller, we are going to use that data. There it is. So this should read response that data. That would be a better name. The data object is the one that contains the array of developers. Right. That object here. A better name for this object. A better name for this object would be just response. Right. And the response contains the status. Right. Some more metadata about the response. Right. And the actual data, which is in this case is an array of developers.
So this developers is just
It's a
whatever
name.
you name it is.
Yeah, it's a variable. You can call it your primary variable, whatever you want, right? It's a variable that you just
You use developers in the data and in the server side.
on the client it's just a JSON object.
Yeah, so I thought it would be you had to pair it to.
No, again, all this is naming conventions. Nothing is enforced. Okay, only the Mongoose model, the Mongoose schema, and all the attributes in the schema. Those are enforced by Mongoose. Mongoose enforces those names, right? But everything else is only naming conventions, right? And that's one of the criticisms of the mean stack in general, right? That many people consider that it's not a stack at all, right? It's just that there's 3 or 4 independent technologies that work very well together, right? You have AngularJS, right? And you have Express.js, right? Running on Node.js. And they just work very well together, right? But there's no enforcement. There is no compiling of the AngularJS controllers and web services and service clients, right? Knowing anything really about the web services and the data model on the server side. There is no enforced linkage or compilation or validation, right? That any of these meet one another, right? So that if this were a framework, a real framework, like Meteor or Sails or some of these other frameworks, right? They do enforce, right? Some of these things, right? So if you name things one way, they have to be named everywhere else, and everything is validated against, right? When you build, or when you do a build, right, it validates that things match, right? And it finds errors and tells, no, this doesn't match here, this doesn't match there, but just like Angular, right, does some validation for us, right? If we name a controller and that controller we named it one way and we misspelled it, it catches those errors, right? That's the beauty of a framework. Angular itself is a framework. Node.js itself is a framework. Mongoose itself is a framework, but the whole thing is not a framework. Okay? It's a stack that works it's a stack of technologies that work very well together, but in itself it's not a framework. Okay? Make sense? All right. Correct. A better name for this would be just a generic response. Right? A response object, which we know inside it contains some metadata about the response, right? And a data object that can back from the server. Yes.
So in any case, do we require the whole response object over here?
Well, we do because we need the list of developers. Because this is the.
So what I mean to say is in the service.
Yeah.
So if we call the service, then service should directly return the data. We can have just dot data over there, which would directly return the data file.
No, the promise on the server side is not wrapped, right? It's the raw data. It's the raw data of the array of developers.
No, but once we have that data in our service on the client side,
On the client side.
then we will only pass the data.
Yeah, that's what we're doing, right?
No, but we just pass the whole response object. So we can have that filter over there. Is it a better
Filter where?
on the service client service. We do a direct return, right?
Yeah.
Instead of doing a direct return, we can just extract the data.
We could do that. Yeah. So this So this client, what
Yeah.
you're suggesting is that this client, right? This client service, right? That it would handle the then, right?
Yeah.
And then extract the data and just return that. Yes, that could be it. That could be. Although it would be a little more, it would be, adding 3 lines of code. It would still return a promise, right? It would still return a promise, and you still would have here these 4 lines of code. I don't know that it would buy you much.
And we have to handle the error case.
And we have to handle error case as well. Yeah. No, but yeah, there's something to say about should the controller be aware of of these nitty-gritty details of using an HTTP request, right? Although in the error we do want those kinds of statuses to be able to display certain error messages depending on what the error type was, right? So the status could be a meta information that could be useful at the controller level for manipulating the front end, right, and displaying certain messages. Yep. Okay, so now that we have the developers on the controller, we pass it to the view, and the view just renders it as raw JSON, right? The raw JSON, we can show an alert if there's an error. So for instance, instead of just model.error, right, we're going to check to see if there is a model.error. We're going to use a div to render it as in a red box at the top, and include the error message in there. For the developers, we'll just iterate over that array and display it as a table. So here's a table which is going to iterate over that model, okay, and then just display the username for each one of the developers. Okay, so what we want to be able to do is that as I click, if I click on the if I want to be able to edit now the developer, right? Maybe I want to change. For instance, one of the things that I didn't provide was the first name and last name. Right, so I like to be able to go back and edit my email, my phone number, my address, or other things, right? So I like to have an edit page. Maybe this could be my profile, right? And in the and here's my first take in the on the right hand side, I'm gonna use an info sign. Right, so that if I click on that info, it navigates to the edit. Right, it loads that developer from the server. It allows me to edit it. Oops. Right, so it's, and the URL will be developer, edit, and then username. Okay, and that's what the mapping of in config, right, is that will take me to the developer edit page. Right. Once I'm in the edit page, I'm going to add a cancel button, right? So I can navigate back to the list, right? So I can always go back and forth. So if I click on this left, which is this left over here, right? If I click on it, it just goes back to the developer, right? It goes back to / developer, and what I want to be able to do is that when I click on this, I need to be able to load the developer that I want to edit, right? And to do that, I'm going to need to be able to grab the username, right, for this edit page, and then go fetch the record for this particular user. To do that, I'm going to need a controller, right? I need to be able to read the route params from there. So I declare the controller for that. And I added to my list of controllers for the developer. Notice there's 3 controllers, one for listing, one for creating a brand new one, and one for editing. Right. So here's my edit, and right now it just says that it's entering the edit controller would retrieve the username from the route params, right, in the edit controller. In the route params, I'm going to retrieve the username. Once I have the username, I'm going to implement in the web service, in the client service, because I need to talk to the database, to the web service, right? I'm going to delegate that to the client service, right? I'm going to go always to the client service to retrieve data. So the controller, right, when it loads, this should be in an init function. It's not. I forgot to put it in an init function. It should be in an init function. It calls find user by username. That's been delegated to the client service, find user by username, which will talk to the server, right? It's going to use HTTP to talk to the server. I renamed it. Oh yeah, find user by username. I renamed it to find developer by username. Okay. In the controller too, I renamed that. Oh, and I put it in an init function like it should be. Right. Again, that's another convention, right? In the wait, did I do this already? Oh yeah, on the service too. I had to rename it. This is gonna send an HTTP request to the service. So in the client service, on the client service, send a get. So it'll be /API/developer and username. Again, this is a RESTful service, /API. Then the entity, and then something that uniquely identifies that entity. That means that I don't want all the developers. I just want that one developer. Okay, and it's a get, so it's a read operation. So this sends it to the server. The server on the other end catches this incoming HTTP request, mapped to find developer by username, and just echoes that it successfully made it there. Have the username on the server, and we're going to delegate this to the developer model. We also implement find developer model on the model side, and we pass the username from the request parameters, right? So we parse on the parameters, and we pass it along to the developer model, right? Passing the username. We can then query the database. We can query the database by using developer find one, right? Passing username and then the filter, and then again we're still using the callback mechanism. When we get to applications and widgets and pages, we'll switch to the new style of using promises, right? So I can show you. I want to be able to show you that. Here's a promise that goes back to the web service, right? And on the web service, because we added the deferred and returned the promise, the web server is getting ready to receive that promise with a then, right? So if there is no error, then the model just resolves the promise, right, inside of the query. The service receives that, accepts that resolve in the first function of the then, and it sends it back to the client. The client is waiting for the response, so it's ready to send it back to the controller, right? The controller is waiting for this, and the controller now receives in the then, right? This is the promise on the client, right? There was a promise on the server that was handled by the web server, a promise on the controller that was sent by the client service, right? So they're all connected. See that? So this resolve gets handled by this first function in the web service, which sends back a response of the developer, which is sent back by the client service, which is then received by the controller. Again, a better name for this would be response as opposed to developer. The developer is actually embedded in the data. Okay, I should go back and rename these. If there was an error, the model will rejects the promise. The service handles that rejection with this second function, receiving the error and encoding the status 400 and sending it back to the client. The client is already, the web service, the client web service is already responding, right? So I need client service. But on the controller, it handles the error by, right now it's logging it, but what we could do is render it. So this is on the edit side, we send both the developer and the error. But if there's going to be an error, I would put a div that a red div that renders that error. Otherwise, if there is no error, we're going to populate a form, right, that contains all the fields of the developer. Using name, last name, right? Instead of just showing the raw JSON. All right, so now we want to be able to update, right? If I make any changes, I want to go and update the database. So at the top of the edit page, right? At the top of the edit page, I'm going to add this OK button on the right-hand side, top right-hand side, right? And if I click on it, I'm going to notify my controller of the new values for the developer. On the controller, I'm going to declare a new, which is then implemented towards the bottom of the controller. And this is, some people lost points in the homework because they were not following this style. This is John Pappas's style, where you declare all your APIs at the top, you declare all your event handlers towards the top, right? And then implement it down at the bottom, right? Again, this is to make it easier on other developers when they read your code, right? So that they can very quickly at the top of the controller see all your APIs, see all your event handlers without having to actually read their implementation, right? If they want to read it, they can still scroll down and read their implementation, but it just makes it easier on others to use your code. Yeah, so it calls this update developer when I click on that OK button. And now the controller is going to send that new developer to the update developer client service, which is right here, right? We added the update developer on the client service, right? Which is going to receive the developer and eventually is going to send it as a put to the server, right? So here the client service, right, is gonna send a put. See that? A put. Right? Before we did a get with the same URL, right? And that meant I want to read this particular user. Here I'm going to do a put, and the interpretation is that you want to update this user. Again, this is convention. Right? It's convention is not enforced. Right? It's good practice. It's a design pattern, right? That after several after several implementations, developers extended implementations of these kinds of applications, that we have gravitated to these design patterns, right? These conventions, right? So we send the username. It's going to be mapped by username and the developer, the new data for the developer. On the server side, the developer's web service is going to create a new URL pattern that's going to be waiting for this incoming put request that is mapped to this HTTP handler. In that handler, we're going to retrieve the username from the parameters and also the body, right? The new data for the developer, right? With the new username, new first name, last name, whatever, right? And we're going to pass the we're gonna through the developer model, we're going to call the update developer, right? Using the username and pass and developer, the new values, right, for the developer. In the model, we're gonna create this update developer, which is gonna receive the username. We're gonna find the user by username, right? We're gonna update that username, that user in the database, right? So in the model, we're gonna use .update. Right? .update is a new one, right? I don't believe we have we looked at update in the previous one, did we? Maybe, I don't know. So .update does two things. One, it does a select, right? It finds the elements, right? Identifies the records or documents that we need to update. And once it has identified these documents, it modifies them, right? And it saves them back to a database, right? We could have done that using a combination of find and then a save, right? Which is, you know, the same thing when we're doing these fields where, right, the following predicate is true. But it's a combination of fetch, you know, identify these records, and then once you've identified them, apply these updates, right? It's kind of like it's a two-way operation, right? Identify the documents and then update them, right? Put them back. So here this update combines two operations again, right? One of them is the predicate, right? That will identify the documents that need to be updated, right? So that's the predicate. You know, those documents that match this first argument, right? Those whose I want those documents whose username is the username that is being passed as an argument. So this username is a field, right? That's the name of the field, right? And they're gonna be pattern matched against the username argument that is being passed along. Once the update has identified the 1 or 2 or 3 documents that that match this query, then it will apply this update. It'll set, right? It's a $set, $set, right? So $set does what you might expect. It sets each one of the fields to new values. Okay? It accepts an object. It accepts an object where the objects have name-value pairs, where the names, the keys, are the fields you want to change, and the values are the new values that you want to update to. Make sense? But here, notice that we're just passing an object, developer. See that? That's a lazy way of saying I want to update all the fields, right? Because remember, that developer has which fields? Username, password, first name, last name, email. It has all the fields, right? With presumably all the values, right? So update is smart. It will not update fields that are the same, right? If the field username was Januzzi and it's still Januzzi in the object that you pass it, it will not update it, right? It will only update those fields that have differences, right? If you change your first name or your last name, right? Those fields will be updated, okay? Or here I could be a little more discriminative. I could be more specific, right? Instead of providing all the fields, I might provide only one field. Maybe you're changing only your password, right? And maybe you have a URL that all. So this set could take this argument, just a simple object whose field name is password, and the new value for that password. Make sense? Right here, we're doing a blanket update on all the fields. Make sense? Right? Yes.
How we kind of handle the kind of new fields, kind of this once the username is new, we didn't put anything there.
Right. So whatever object that comes in here, right? So there might be fields that didn't have values. For instance, I might not have had a first name or a last name, right? It will do the new values that you provide, right? So if the fields are not in the object, it will not do anything. If the values are the same of the one that are there already, it will not do anything, right? It'll only update them if the field was not there, and now you're giving me a value, right? It will set it to this new value. Or if the values were different, it will update those values. Okay. So yeah. So this is this here. The set is a shortcut for having written something like okay, and then username colon whatever the value of the developer is. So the new username, comma, first name, new value, right? So this goes through each one of the fields, right, and gives them these new values, right? These don't have to be all the fields in the schema. It could be a subset of those, right? Maybe I only want to change my first name and last name. Maybe I don't want you ever being able to do this, right? You should not be able to change your username, for instance, right? I could enforce that here. Could do in the developer, when the developer object comes in, and I want to make sure that you never update your username, right? I want to make sure that the developer does not have the username field, because if not, it is going to change it for me, right? Even if so, I want to make sure that if you post or if you put, right, maybe with poster or something, right, and you send me a value for the username, right, which might be different than I'm going to remove it, right? I can either do this explicitly, those fields that I do want to change, right, or I can delete developer.username, meaning if you had a username field in there, right, I'm going to remove it, making sure that I'm not going to update the username, for instance, right? Now this one is for updating the developer, the entire object developer, right? I could have things that are more granular, things that allow me to change only my password, right? Only my personal information, only my phone, only my address, right? So I could be as granular as I want, right? This is a change my entire developer object, right? Which is somewhat not granular at all, right? It's very, very broad change. Anyway, once the update is made, I get a status object back saying how many records were updated, right? And if it was successful, it was okay, or these are all the documents that matched. There were 30 documents that were matched, but I only was able to update 25. Right, so I get that kind of statistics in the status variable, right? And then I might handle it as an error or not, right? I might reply back to the client saying, only I wasn't able to update all the documents. In this case, there's only one document that needs to be updated, right? Because username presumably is a unique field. Yes.
And why we don't use find one?
Find one.
So.
Oh, yeah, that's what I said earlier, right? We could have used a combination of find and then a save, right? Update does both, right? It finds that record, right? And then it updates those that match.
No, but if we are sure that only one username exists, then we can have a find one, because because find one would throw an error if there are multiple.
It doesn't throw an error; it just grabs the first one. Yeah, if it matches more than one, it just only looks at the first one. Yeah. So here as well, right? Well, first of all, we are assuming that it's only that the username is unique, and you can enforce that on the schema. On the schema, you can say, this field is unique. It's not the primary key, but it's unique. That means that when we insert or update, right, it will verify that, right, that you haven't modified it to something that is not unique, right? That is and so when you make those enforcements, then this update is just fine, right? It will only match ever one. Okay. Yes.
Suppose this update developer is called from two different sources. Let's say example, user is updating and one admin is updating.
Yeah.
And admin is suppose allowed to update the username. So is it the right idea to filter the developer object in the model? Because the source is coming to the same API, so it's going to be called the same function.
Yeah, probably you'll want to have APIs that are specific to the different end users, right? And it will have, probably one of them will be public and accessible to anybody, right? That for instance, all the gets will be public. Anybody can read this, but then all the updates all the posts, and some of them will be only accessible to the admin, right? Where one of them might be public and don't need logging in and they're public APIs, right? Anybody can read them. The admin usually will ask for authentication, right? And it will be URL that doesn't follow standard URLs, right? So you'll put it under some /admin something or other, right? That will be protected, and we'll do that next week when we do security on mean applications. We have to protect two things, right? Not only do we have to protect the static content, whether you can view a page or navigate somewhere else, right? Or make sure that you're in the right role, or you say who you say you are, right? And we protect different sections of the application. We also need to protect another thing, which is the URLs, because these URLs are also as public as anything else, right? Anybody knowing our application and hitting a delete, it knows what the URL is, and looking at the you can see exactly what the URLs are, right? And then because I can use poster, right, and send those commands, right, and just make myself an admin, right, and I have full access to the database, right? So yeah, so yeah, those certainly we have to consider protecting things that are accessible to admins. Yes, and we'll do that when we get to Passport next week. Okay, so we return the promise from having updated the developer. Right, so in the we handle the if there's no error from within the update, we resolve. That means that on the web service we return a 200. And on the client, we return the HTTP request, and on the controller, we handle the success, right? If the promise is rejected on the model, we handle the error on the web service, and on the controller, we handle the unsuccessful response, right? Does it go to 30 or 25? 30, right? Yeah. And if it's successful, right? If having edited the developer was successful, we're going to use the location service, right, to navigate to the developer, the list of developers. Otherwise, we do not navigate away, right? And we display the error on the page. I added a delete button at the bottom of the edit page. Added a delete button at the bottom of the edit page with an event handler in the controller that is handled right here, right? And this is going to go just use the web service .delete, right, to remove the developer from the database. All right, I'm going to leave it here. I'm going to send a invitation for later this afternoon for office hours if you want to chat. All right, thank you.